Assalamualaikum and very good day to all audience and delegates to MIHA International Convention and Exhibition 2022. I'm Umar Ab Aziz from Petronas. Would like to share with you our learning experience in establishing and implementing the chemical reactivity matrix for a complex warehouse. First of all, here is the content of my poster presentations. In the introduction, I will cover the objective and expected learning outcome. Also, I will set the purpose of the chemical reactivity matrix or CRM, and as well as background of warehouse facility, which the CRM is established for. In the technical sharing, which is the main content of this presentation, I will share with you the methodology of CRM development and also the challenges that we face during the CRM development. To wrap up my presentation, I will again reiterate the learning outcome and to summarize the conclusion of my presentations. The objective and learning outcome. The objective, if we want to share the methodology and challenges encountered during our task in establishing the chemical reactivity matrix, and then to share efforts and mitigation that we have done to overcome all those challenges. The learning outcome, we have to have the right selection of main component of chemical so that we can come up with a good CRM before we use the CRM software. We should have a good reference to various standards to help us in deciding the hazard classification of chemicals. And then translating the CRM into warehouse layout is not simple. We have to do some adjustment so that it can be more realistic and workable. So what is the chemical reactivity matrix anyway? Actually, it is a set of charts showing the compatibility among chemicals which will be stored or being stored in the same area or same locations. Then why need a CRM? Because we want to avoid any hazardous reactions or hazardous incident due to accidental mixing of two or more chemicals which is incompatible with each other. We have experienced some catastrophic incident globally related to chemical storage. For example, we have incident in Texas 2013, and then Tianjin in 2015, and recently Lebanon explosion during 2020. Okay, other than that, we need CRM to comply with the company standard. Specifically the Petronas standard, where each chemical storage require to establish CRM prior to be used. Okay, so the arrangement of chemical or layout of chemical inside the storage must align to the CRM generated for that particular warehouse or chemical storage. Okay, this is the geographical locations of centralized storage building or CSP, which the CRM established and will be discussed in this paper is meant for this CSP. Okay. It is located at south of Peninsula Malaysia, specifically in Pengerang Integrated Complex, or we call it as PIC. This CSP consists of two main parts. The first part is open yard and the second one is warehouse building. The yard area is about, open yard area is about 320,000 square feet, while the area of warehouse building is about 84,000 square feet. The area of warehouse building is equivalent to almost 2 times of soccer field. Okay. This chemical building or warehouse building houses many chemicals, wide range, ranging from flammable, liquid or solid, up to miscellaneous hazardous material in many form and storage. Okay, here comes the content of my presentations, which is the technical sharing. First, I want to share with you the methodology and developing CRM and warehouse layouts. The first step, we have to gather chemical details, all the list of chemical, the properties, the components, and then we have to decide and access the main component to map with software database. The first 2 steps is a preparations that we have to do before we use the software to generate the CRM. Third step is to key in the chemical into software to generate the desired CRM. Lastly, we have to develop the chemical arrangement or layout in CSB in line with the CRM. And during this stage, we have to do some adjustment so that the chemical can be suited into the spaces in the warehouse. Okay. In details, gather chemical details mean we list all the chemical using the commercial names, and then from that commercial name, each chemical is break down into its ingredients or component. Okay, and then after we identify all the component, we have to decide the main component of that particular chemicals following the criteria that we have selected. Okay, to do this, we have to decide whether the chemical is a single substance or mixture. If it is a single substance, it by itself is the main component. If the chemical have many ingredients, we have to choose the most hazardous one or most reactive one as a main component. Or if all the composition or ingredients have the same hazard category, so we have to choose the most percentage constitution as the main component of that chemical. So that's the preparation that we need to establish before we can use the software. Okay. When the preparation is ready, then we can key in the chemicals details into software to generate the required CRM. Okay. If you can see the list in the left, we have chosen the main component, and we translate all the main component into the chemical reactivity worksheets to generate the desired CRM. Okay, so the outcome of the software is the chemical reactivity metric that we want. So in the right side of the slide, this is the warehouse chemical reactivity matrix that we have generated for CSB 501. Okay, you can see the charts shown many colors indicates type of compatibility. Red denotes as not compatible. Two chemicals cannot be arranged together. They have to be separated. C means caution. We have to store them with extra precautions. And for yellow, it's okay to store together side by side. And for amber, it is going to be a separative if we store it together in the same place. Okay. Then after we have generated the CRM for all the chemical. Now we can start thinking how to translate this CRM into a workable layout or chemical arrangement in the CSB or chemical warehouse. So this overall chemical applied to a common area in the warehouse where all chemical at any time can be placed there. Okay, CRM then is trimmed down to smaller sub-CRM for individual partition in the warehouse. When doing this, the chemicals is arranged in according to the safe distance established by standard reference such as UNDG and others for chemical denoted as yellow, amber, and reds. Okay, for example, we have decided to isolate the item in range which are incompatible each other by separation at least 5 meters or more. For chemical with yellow category, we separate them by 5 meter distance, whereby the chemical which are self-reactive if stored together, we separate them by 5 meters. Okay, this is the final layout of CSB. As I mentioned earlier, the overall CRM applied to common area J, denoted as J area. The activity take place in J area are receiving and transit activity, which involve all chemicals. Okay. This CRM then is trimmed down to smaller sub-CRM for individual partitions, denoted as A area up to I area. It includes co-room, oxidizing agent, combustible room, flammable room for gas, solid, and liquid. Okay. Okay, after knowing the preparations and other mechanism in developing the CRM, now I would like to share with you challenges during the process of developing the CRM and establishing the warehouse layout. In terms of size, we have more than 360 chemical listed and to be stored in the CSB. And this can sum up to more than 6,000 number of different packaging of various size from small to large, small can, pail, drums, bags, jumbo bags, boxes, and up to ISO tanks. Okay, this number of chemical keeps on changing. So to overcome this issue, we set up a task force team comprises the chemical buyer, the user, the warehouse operator, and the forwarder to sit down to firm the number of chemical and to really decide which chemical to be stored in specific area in the building or in open yard. Okay, in terms of tools, we have experienced frequent system glitches because we are dealing with the big data. The computer always crash with high RAMs, and then the software itself can simulate up to only 100 hazard or function group only. So in order to overcome this obstacle, we have developed a data backup. We have set up teams to have a backup data, extra computer, and then we do detailed checking on criteria selection so that we cannot burden the software. In terms of environment challenges, we have space limitation at current warehouse meaning to say the current warehouse is already built before we develop the CRM. So the warehouse come with permanent partitions with different sizes and different level, different ventilations and all that. Okay, to overcome this problem, we develop additional CRM, just a breakup from main CRM for each individual partitions and place same group of chemical in the same partition. This is to make the generation of sub CRM is much simpler compared to the main CRM. To wrap up, I would like to reiterate again the learning outcome of my presentations. First, we have to have the right criteria. Never make mistake in selecting main significant component of chemicals. Otherwise, it will yield or generate the wrong reactivity matrix. Right reference. Do refer to various reference in deciding the hazard classification, the right hazard classification of each component, and do adjustment when translating the CRM to workable warehouse layout because the CRM cannot simply translate it to the existing warehouse due to the design and spaces that have been constructed already. So in conclusion, preparation is very critical before running the chemical reactivity worksheet software to avoid wrong selection of chemical criteria. Wrong selection of criteria mean we generate a wrong reactivity matrix, and this may lead to hazardous accidents. Developing a warehouse layout for chemical storage shall align with the CRM. However, if there is a need to change due to certain conditions like space constraint, use various standard reference to help in making adjustment. So with that, thank you very much for your listening.